All right, so 3.3 is going to be one of the hardest things we talk about pretty much all year. So it's solving equations with variables on both sides of the equal sign. So the first thing we do, just like before, is always draw the river. Sometimes there's going to be distributive property, like there is in example 2. So you're going to want to distribute first and then combine your like terms, if possible, is what that should say, if possible. Oh gosh, all sorts of typos. Okay. Then step 3 is get both variables on the left side of the river. So you want all your variables on one side, in this case the left side, and all of the numbers on the other side or the right side of the river. And then once you have that, then it's just solving it. Okay, I know I made it sound kind of simple. And once you get in the swing of things, it is a little simple, but we'll talk about this, okay? So looking at example 1, let's first draw the river. Then we said we wanted all of our variables on the left side. So we want our x's on the left side and our numbers on the right side. So what I mean by that is I want to move this variable, this 10, to the other side. So I'm going to move that to the other side. So this is a positive 10, so I'm going to subtract 10x on both sides. So I'm subtracting 10x. These x's cancel. 3 minus 10 is negative 7x. I haven't done anything to this 10, so he comes along. I bring my equal sign down, and now I'm left with a negative 4 over here. So I'm still not done because now I want to get this 10, this number, on the other side. So this is the plus 10, so I'm going to subtract 10 on both sides. Because remember, I want just my x's on one side and just my numbers on the other. So now these 10s are going to cancel. I bring my negative 7x down. Negative 4 minus 10 is negative 14. And now we solve. We solve like we normally would. Here's multiplication. We undo multiplication by dividing both sides by 7. Our 7's cancel. We have x. Bring our equal sign down. Negative 14 divided by negative 7 is a positive 2. So again, we were moving our 10x to the left, and we were moving this 10 to the right, because we want all of our numbers on the right and all of our variables on the left. Okay. So number 2, example 2, has something else here. So of course we draw the river, and we want our x's on one side, our numbers on the other. But first we have to distribute. So distribute first if possible. So we're going to distribute that 2 into everything in the parentheses. So I'm going to get 2x plus 12 equals 6x. Now I want to move this 6x over to the other side. So I'm going to subtract 6x on both sides. Okay. 2 minus 6 is negative 4x. Bring your 12 down. Bring my equal sign down. On this right side, what's left over here? 6x minus 6x gives us a 0. And that's okay because I'm not done. I still need to move this 12 over. So the opposite of a positive 12 is a minus 12. Our 12s cancel. We bring our negative 4x down. And 0 minus 12 is negative 12. Now it's a normal equation that we can solve by dividing both sides by negative 4. And that's going to give us x equals 3. X equals 3. Okay. We're going to do example 3 now. I'm going to do one more with you. I'm going to have you try example 4 then. Okay, so we always start by drawing the river. Again, we want our x's on the left, our numbers on the right. So we're going to first distribute. So I'm going to bring my 3x down. 8 times 2 is 16x. 8 times 6 is 48. A positive times a negative is a negative. And we haven't done anything to this right side, so we just rewrite it exactly how it is. Now we have like terms, so we can combine 3x plus 16x, which is going to give us 19x. We didn't do anything to this minus 48. We still haven't done anything to this 2 plus 14x. Now, we need to get this 14x to the other side. So we do that by doing the opposite of adding 14x, and we subtract 14x on both sides. These 14s cancel. 19 minus 14 is 5x. Bring my minus 48 down. And then we're left with 2 on this side. Okay, so now we have to get this 48 to the other side by adding 48 on both sides. Those 48s cancel. We bring our 5x down. 48 plus 2 is 50. Now we divide by 5. And we're going to get x equals 10. X equals 10. Okay, I want you to try example 4 on your own. This has distributive property on both sides. So try this one on your own, and then I'll walk you through it. All right, so you should have also gotten x equals 10 for this one. Okay, so you should have also gotten 10. When you distributed, you should have got 6x minus 6 and 9x minus 36. You had to move that 9x over. So we're left with negative 3x minus 6 equals negative 36. Add the 6, and then divide by negative 3. Okay, looking at example 5. Since you were so good at example 4, I want you to try example 5 for me. So get as far as you can on example 5. All right, so hopefully you distributed the 3 to the x and the 4. So you got 3x plus 12 equals 3x minus 7. And then you had to subtract the 3x. And when you subtract that, you're going to get 0x. So, and then because I have 0x, I don't need to write that. So somehow I got 12 equals negative 7. Is 12 equal to negative 7? Is that true? Hopefully in your head you're saying, no, that is not true. When you have two things that aren't equal to each other in an equation, that's technically called a no solution. That it has no solution. Or sometimes you might see it as a null set. And why again? Why do you think this is no solution? Well, we know that 12 does not equal negative 7. So this is false. So we can't ever actually solve this problem. There's a symbol that we have with this. If it's no solution, you could write no solution, or you could draw a 0 with a line through it. That means no solution. So sometimes on our worksheets or something, I'll draw this afterwards or write no solution. So you can't just leave it like this. I need to see either one of these or both. Okay, so that's the first one. Something's going to be a little different about number 6, so I want you to try it and see if you can figure it out. So hopefully you got that 8 was equal to 8. Is that true? Hopefully you said yes, 8 does equal 8. So this is called infinite solutions. So this is called infinite solutions. And because 8 does equal 8, then it's always going to be true, no matter what we put in. So no matter what we put in, no matter what we plug in for x, the statement, the equation will always be true. Okay, and there's a symbol for this as well. The symbol for this is the infinity symbol, which is kind of like a sideways 8. So if you turn your paper sideways and draw an 8, there's your infinity symbol. Okay. Yeah.